You have a graph. They say this is graph x, right, unit meter divided by graph t unit second. So this is a graph displacement versus time t, or distance versus time t. So figure show the graph displacements against time t and object moving alone at x axis. Calculate average velocity for the time interval 1 to 4. So meaning we have the time here 1 to 4 seconds here. So what is the average velocity? So to calculate the average velocity, so look at the definition. Average velocity, we have the change of displacement divided by change of time t. So change here is a final displacement divided by initial displacement and divided by the change of time t final, t2 minus t1. So if look at the relate to the definition, so meaning here the S2 from 1 to 4, the final velocity is a minus 3. This is a minus 3. And initial velocity is a initial velocity here for the 1 here we have a, for 1 second is a 2. So we have a 2 here. And this is minus 3 minus 2, and the T2 is equal to 4. This final time and initial is equal to minus 1. So now you have a can use the calculator here. So we have V average. This is number 1, right? 1. V average is equal to negative 1.67 meter per second, because this is minus 3 and minus 2 here. Okay, right? So this is average velocity. So next question is average speed. So how to calculate the average speed here? So we have equations, also the symbol. This is average speed and this is average velocity. So we have a value of the for the average speed, you must find the total distance. From 1 to 4 is a distance for the 1 second is 2. 2 to 4 we have a distance 2 meter. And the next moving object from 4 here to 0, meaning the distance here is a 4. And now the next process moving from 0 to 3, so meaning you have a extra 3 meter. So this is total distance. And the total time here we have a from 4 to 1, meaning we have a 4 minus 1, or in 3 seconds. So now we have the value of the average speed is 3 meter per second. This is number 2. And the next is number 3. So number 3 asks you to find the instantaneous velocity at 2.5. Let's say you look at the graph here. Let's say here 2.5 here. This is 2.5. So how to calculate instantaneous acceleration? So if you look at the definition, instantaneous acceleration, the time t, time and the t is 2.5 seconds, is use the value of the displacement. Okay, use a delta x here, and we have the value of the time t, or not the change of value. This is a dx, meaning here what is the distance here at 2.5, right? At 2.5. But if you look at the graph here, if you calculate, this is straight line. If you calculate the graph here, we have a constant value because we have a straight line. So meaning here you can find the gradient of the graph here by using the equation. Using the first here. If you find the gradient here, use a triangle here, right? So this is a final displacement, and this is initial 4. So many you have because this is negative, right? So this is negative 3 minus 4. We have 4, and divided by t is a t here. You can use a 3 to 2 here. We have the gradient, right? So this is a 3 minus 2. So now you can find V instantaneous at the time 2.5 seconds is equal to negative 7 meter per second. Alright. And number 4, instantaneous acceleration at t 5.5. So here, if you look at the equation, the graph here, this is 5 seconds, and let's say this is a 5.5 seconds. Let's say the value here, 5.5 seconds, right? But the question asks you to calculate the acceleration. So if you look at the graph here, this is straight line graph for the for the displacement. So meaning we have a constant value of the v. So here we have a v constant. So what happens if you have a constant value of t, no change of t? So meaning if you if the question asks you acceleration, so acceleration must is equal to 0. So no acceleration from 5 to 6 seconds of instantaneous acceleration 5.5 seconds, right? Continue number B. So use the right. This is small, big, right? B, a stone thrown vertical. So meaning, let's say you have this is a ground surface, and you have the stone or object, right? And thrown upward. So meaning you thrown upward with the initial velocity 24 meter per second. This is the initial velocity, right? And number 1, the displacement. So meaning after 4 seconds, right? When the t or after 4 seconds, what is the displacement here? What is a displacement? Or I can use the symbol h or s, right? I after 4 seconds. So here you can use the equation or the formula, right, to find the displacement of the stone after 4 seconds. Okay, you can choose the equation s is equal to ut minus half gt square. And this is the process only on the y-axis or vertical axis. So you can refer to the x here is a y and the uy here. So now, okay, sy. So this is the question asks you to calculate the sy after 4 seconds. So the time here is a 4. This is 4, and it is t also 4, and the g constant value 9.81. And you can find your uy is given by the question is 24, right? This is 24. So now you can find the value of the sy. You can use the calculator. Is 70.52 meter. So this is the displacement of the stone after 4 seconds, right? And the number 2, velocity stored at the 10 meter above from the off launch. So meaning, let's say when the ball moving upward, when the height of the object at the 10 meter, so what is the value of the velocity? So this number 1, okay, number 2. So meaning to calculate the velocity here, you can use the equation v square is equal to u square minus 2gs. Why you use the equation here? Because we have a value of u, because u is given is 24 meter per second, right? And we have the value of displacement when the height of the object from the ground is 10 meter, right? 10 meter, right? So g is constant 9.81. So now you can find the value of the speed at the 10 meter from the ground is 19.49. So we have a negative value here, meter per second, right? Okay, the next, time to reach the maximum height. Time to reach the maximum height. Okay, if you look at the, okay, so meaning the objects moving upward, and after that, before the object start moving downward, so at the position, the maximum height, we have a final velocity v is equal to 0. So now you can, here you can use the first, the information you have a initial velocity, you have a final velocity. So to calculate the time to reach the maximum here, so meaning from the ground to the maximum, what is the time here? Okay, you can use the equation v is equal to u minus gt. Why you can use the equation? Because of we have the value of v, the final is equal to 0. Initial we start moving object 24 meter per second, and g is constant 9.81. So you can find the value of the t. So right here the value of the t, you can use the calculator, is 2.45 second, and unit is a second, right? So that's all. See you on the next video. Thank you.